The elements of the safe systems approach. Safe roads and roadsides, encouraging appropriate travel speed. Safe speeds, setting speeds that are consistent with the functional classification of the road. For example, if you're driving on a major urban road that is either arterial road or the subarterial road, you would have a certain speed that shouldn't be changing often, okay? If you're driving on the local road, you should have a lower speed, and that speed, again, should not change often. Safer vehicles, vehicles that protect occupants and road users. Road users who are being alert and compliant. Concept of travel time reliability focuses on designing a roadway in such a way that maximizes the travel time reliability of the roadway. The goal, to make travel time more consistent and thus reduce day-to-day variations in travel time on given section of road. And travel time reliability, it takes travel time more consistent and thus reduces day-to-day variations in travel time on a given section of a road. Design that can reduce the potential impact of non-concurrent congestions on travel times. Key sources of non-concurrent congestions: traffic incidents, special events, work zones, traffic control devices, such as traffic signals, and obviously weather. Concepts of value engineering. Value engineering is a systematic process of a project review and analysis by a multidisciplinary team to provide recommendations for improving the value and quality of the project. Goal, to improve the value of design by modifying any aspects of the design that would result in an increase in value. Goals are similar to practical design, but potentially seek not only the same or better project performance at lower cost, but also better performance even at the somewhat higher cost. All of these concepts profess to consider a broad range of design issues, but each concept has been advocated by interest groups or adopted by the road agency with the specific priorities in mind. The advocates of each of the alternative concepts, recognizing the need to consider competing viewpoints in the design of the major roads project, and likely consider themselves to be seeking project designs, then consider and balance all competing stakeholder goals and interest, but their choice of the alternative concept may advocate often tells something about the factors to which they assign a high priority. The stated goal of a completed street concept, for example, is to consider all transportation modes in the design of urban and suburban arterials. Most advocates of complete street emphasizes explicit consideration of bicycle and pedestrian needs. The stated goal of the context-sensitive design is to assure that each road project is designed in a manner consistent with the context of the road. Most advocates of the context-sensitive design advocate strong consideration of community, neighborhood, and environmental values. The stated goal of the performance-based design is explicitly consider operations and safety. It needless to say that all of the alternative concepts have useful features that should be considered in developing a revised geometric design process. Yet none of these concepts by themselves are a complete and sufficient process for identifying and considering all factors relevant to design decisions. Each of these alternative concepts is reviewed and should be reviewed by you as a designer and discussed with a client and seek to seek the most appropriate concept that should be used for geometric design of major road in an area that has been planned by the client. Each of these concepts should be used during development of the performance-based design. Performance-based design incorporates a design process that considers explicit consideration of performance measures, typically operational and safety performance measures. In performance-based design, each design decision should be explicitly assessed in terms of its potential impact on operations and safety. Performance-based design should be consistent with goals identified or set up by a roadway agency of moving away from design for minimal safety, meeting specific geometric design criteria, towards substantive safety, meeting explicit performance criteria. Carried to its logical conclusion, performance-based design could have the goal of meeting specific operational and safety targets established by the road agency for each major road project. A performance-based design process involves, at a minimum, estimating the operational and safety effects of each design decision for which it is feasible to make such estimates with available tools, and so consider those operational and safety estimates explicitly in making geometric design decisions. Typically, many factors other than operations and safety are considered in the geometric design decisions, so the operations and safety will not necessarily be the deciding factors for all geometric design decisions in all projects. But clearly, designers recognize operations and safety as an important decision factors. A performance-based design process with goals based on the both operational and safety targets is now feasible for majority of the major road projects. The current state of practice already include a performance-based design processes with the goals based on operational targets, such as level of service. And I hope you're familiar with that terminology. If not, I'm sure you'll find out in the various standards. So what is the primary road purpose? The primary purpose of the road is to enable the safe, convenient, effective, and efficient transportation of persons and goods. Roads may serve other purposes such as moving vehicles, parking vehicles, provision for pedestrians and other non-vehicular traffic, access to abutting properties, access in a case of natural disasters, improved defense capability, improved availability of health, emergency, and other essential community services, and increased potential for a range of economic land use. It should be clearly recognized that roads form but one element of the total transport system, which may include all forms of transport by land, sea, or air. In a properly coordinated and integrated transport system, all appropriate forms of transport should be used for their best or optimum use. Road classifications. In Australia and New Zealand, there are several commonly used type of road classifications: functional, funding, administrative, and road amenity. Functional classification is the most commonly used and classifies roads on mainly arterial, subarterial, collector, local, and the most commonly used. Funding classifications classify roads as a national, state, and local roads depending on the level of government primarily responsible for funding. Administrative classification is adopted by the various road authorities to suit their own particular needs. And road amenity classifications recognizes the requirements of the different road users, truck, cars, pedestrians, cyclists, public transport, and non-traffic functions of the road. On the international level, the hierarchy of the major urban roads accepted today generally falls into the three categories. The category number one, urban freeways. The category number two, urban roads and streets. And the category number three is the traditional streets. As the subject of my lectures are major urban roads, I'd like to define urban areas. They can be defined as developed places within the boundaries set by responsible state and local authorities. Urban areas have fundamentally different characteristics from the rural areas with regard to land use, density of road network, nature of travel patterns, and the way in which these elements are related. I suggest the following definition. The major urban roads are the roads through urban areas serving the major centers of urban activities. They generally have intersections at grade, provide access to abutting properties, and carry traffic in which a greater parts have neither origin nor destination at the abutting property. The term major urban roads excludes streets, collector roads, distributor roads, freeways, motorways, and the expressways. There are two categories of major urban roads: urban arterial roads and the urban subarterial roads. Urban arterial roads are the roads that carry high volumes of through traffic and link the large urban activity centers. The urban subarterial roads are roads that connect arterial roads to the areas of the urban development. You can see this classification on this little sketch, okay? So you can see the arterial roads, major urban arterial roads, subarterial roads, and the collector roads.